Let us look at an example of forecasting using the linear regression analysis. Maxis Sales Corporation is in the business of selling laptops. They realized the advantages of forecasting very early in their business. They also realized that in order to perform effective forecast, they need to keep track of their current and past sales numbers. Currently, they are in the process of forecasting their sales numbers for each quarter of the coming year. In order to do this, they have pulled up their sales numbers for the last 12 quarters. These numbers have been given to us in this table. So for each quarter, we have been given the sales figures. So for the first quarter, their sales were 600. Now this is all in terms of units. For the second quarter, their sales were 1550 units, third quarter 1500 units, and so on. Use the least squares method to find forecast for the next 4 quarters. So we have to find the forecast for quarter number 13, 14, 15, and 16. Also, find out the standard error of the estimate. Now in linear regression analysis, there are two types of variables. First one is the dependent variable, and second is the independent variable. So in our case, time, which is expressed in terms of quarters, is the independent variable, while sales is the dependent variable. So as it clearly is understood here, the number of quarters is not dependent on the sales, but the sales figures are varying by the number of quarters. So the dependent variable is the one that we want to forecast, because we want to find out the forecast for quarters 13, 14, 15, 16 in terms of sales units. In linear regression analysis, the relationship between the variables is assumed to be a straight line. Now the equation of a straight line is generally noted as y is equal to mx plus c, where c is the constant and also the y-intercept, and m is the slope of the straight line. In linear regression analysis, it is commonly denoted as y is equal to a plus bx. Here y is equal to the dependent variable for which we are trying to solve. A is equal to the y-intercept, B is the slope, and X is the independent variable, which in this case is time. So basically, A is nothing but C in this case, because A is the y-intercept, and in our normal equation of a straight line, C is the y-intercept. And B is nothing but the slope of the line, and x and y remain as it is. So basically, if we plot the sales figures for the data that has been given to us, then the graph will look something like this. Let's say time is on the x-axis, because x-axis is the independent variable, which is time, and y-axis is the dependent variable, so this will be sales. Now I'm not plotting this to scale, but the points, if we try to plot on this graph, will look something, let's say, like this. So this is nothing but the sales data. Now the least squares method is used to determine the line that can be drawn using these points such that the sum of the squares of the vertical distances between each data point and its corresponding data point on the line is minimized. So let's say we draw a line here. Let's say this is the line. So this is the regression line. Now corresponding to a value on the x-axis, we will have a corresponding point on this regression line in relation to this sales data. So let's say this is y, and here we will have y dash. So this distance is known as the deviation. And we have to draw this line in a way that the sum of the squares of the vertical distance between each data point, which in this case is represented as y, and its corresponding data point on the line is minimized. So basically, if you calculate this distance and then square each of these and then add the squares of these distances, then that should be minimized. Then we'll say that the regression line is a good fit. So basically, in other terms, what we want to minimize is y1 minus y1 dash square plus y2 minus y2 dash square plus so on till y12 minus y12 dash square. In this case, I'm taking 12 because we have 12 quarters. So once we get this line which is the best fit based on the data points that has been given to us, then if we extend this line to the future quarters, then we can get the value of sales corresponding to a time period. So if we draw this in a graph to scale, then using this technique we can then find out the sales numbers for the future quarters. We can also find out the numbers for the future quarters by using a formula method. So using the formula, basically we have to find out the values of A and B. And once we have the values of A and B, then if we put the value of X, which is the quarter number, then we will get the corresponding value of Y, which is the sales for that particular quarter. Now A can be found out by using the formula. A is equal to Y bar minus BX bar, and B is equal to sigma X Y minus N X bar Y bar divided by sigma X square minus N X bar square, where A is the Y intercept, B is the slope of the line, Y bar is the arithmetic mean of all y's, X bar is the arithmetic mean of all x's, X is the x-axis values of each data point, Y is the y-axis values of each data point, and N is the number of data points. So here basically for A, what we have done is we have brought bx on the other side, so it becomes y minus bx. Now since we have multiple values of x and y, we are considering the mean values of x and y, that's why x bar and y bar. So A is derived from here, but A can be derived only if B is known, and B is equal to sigma xy minus n x bar y bar divided by sigma x square minus n into x bar square. Now one easy way to remember this is basically if you remember the numerator, sigma x into y minus n x bar y bar. In order to arrive at the denominator, replace y's with x. So basically what this becomes is x multiplied by x, which becomes x square. So minus n multiplied by x bar into x bar. So x bar into x bar becomes x bar square. So denominator becomes sigma x square minus n x bar square. So let's proceed to find out these values. So here I have noted down the values of x and y, which in our case x is time and y is the sales. Now first we'll try to find out the value of b. So in order to find the value of b, we have to find out the values of x multiplied by y for each of these quarters, and then we have to add them up. So let's first find out x multiplied by y. So 600 multiplied by 1 is 600. 1550 multiplied by 2 is 3100. 1500 multiplied by 3 is 4500. 1500 multiplied by 4 is 6000, and so on. So let me calculate all these remaining values. So these are all the values of x multiplied by y, and we need to find out the sum of all these values. So let me do the total. So the total is 268,200. Now next we have to find out the multiplication of n, x bar and y bar. Now x bar is nothing but the average of all the values of x, and the average will be the sum of the values of x divided by n, which is the number of values. And y bar is similarly the sum of all values of y divided by n. So let me find out the sum of all the x's and the y's. So the sum of all x's is 78. So this becomes 78 divided by n, which is 12. So this is equal to 6.5. Sum of all y's is 33,350 divided by n, which is 12. So this becomes 2779.17. So now we know the sum of the multiplication of x and y. We know the values of x bar, y bar. We also need to find the sum of the values of x square. So we have x, but we don't have x square. So let's find out the values of x square and then add them up. So x square, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, and so on. Let me put the values here. So the total is 650. So now we have all the values that we need to calculate b. So let's proceed and calculate b. So b is equal to sum of x, y, which is this. So 268,200 minus n, which is 12, multiplied by x bar, which is 6.5, multiplied by y bar, which is 2779.17, divided by sum of x square. So this is x square, sum is 650, minus n, which is 12, multiplied by x bar square. X bar is 6.5, so 6.5 square. So let me pull my calculator here. 12 multiplied by 6.5 multiplied by 2779.17. Enter. So this is 268,200 minus this value here. So this becomes 216,775.26 divided by 650 minus, so 6.5 square multiplied by 12, that is 507. So this is equal to 268,200 minus 216,775.26. So this is 51424.74 divided by 650 minus 507, which is 143. So this is equal to divide by 143, so 359.6. So this is the value of B. Now we can plug in this value into this equation to find the value of A. So let's do that. So A is equal to y bar minus bx bar. Y bar is 2779.17 minus B, which is 359.6, multiplied by x bar, which is 6.5. So this is equal to, let me pull the calculator here. So 359.6 multiplied by 6.5 minus, and add this to 2779.17. So the value is 441.77. So this is equal to 441.77. So this is the value of A. So at this point we have the values of both A and B. So we can come up with the equation of the regression line. So let us plug these numbers into that equation. So the equation of the regression line is y is equal to A plus bx. So plugging in the values of A and B in this equation, so y is equal to 441.77 plus 359.6x. Now, as per the example, we have to find the value of sales for the 13th, 14th, 15th and 16th quarter. So in place of x, we'll put the values of 13, 14, 15 and 16, and we can find out the corresponding values of y. So let us do that. So y for the 13th quarter is equal to 441.77 plus 359.6 multiplied by 13. So this is equal to 5116.57. Similarly, y for 14 is equal to 441.77 plus 359.6 multiplied by 14, and this is equal to 5476.17. Y for 15 is equal to 441.77 plus 359.6 multiplied by 15, and this is equal to 5835.77, and y for 16 is equal to 441.77 plus 359.6 multiplied by 16, and this is equal to 6195.37. So these are the sales figures for the 13th, 14th, 15th and 16th quarter. Now in the next part of this video, we will find out the standard error of the estimate to evaluate how good this regression line was.